Hello students, welcome to Lucky Learning. In this video, we are going to discuss one of the important topic called main memory. And you know that CPU can communicate only with main memory, not with the secondary memory, because the stored programs are there, means backup programs are there in the secondary memory. Whenever it is required to be executed, it has to bring into main memory. From main memory, CPU can read the programs as well as data, so that CPU can execute those programs against the data. So here in this video, I am going to discuss the importance of main memory and how main memory is composed and how it is going to be designed. We know that the main memory is the central storage unit in a computer system. The principal technology used for the main memory is based on semiconductor integrated circuits. It is a meaning that main memory is designed using semiconductor integrated circuits. Most of the main memory in general purpose computer is made up of RAM integrated circuit chips, but a portion of the memory may be constructed with ROM chips. It is a meaning that main memory, it is not mean only RAM, it is a combination of RAM and ROM chips. As you know that RAM is random access memory and ROM is called read-only memory. And there are two possible operating modes for RAM called static RAM and dynamic RAM. Random access memory. Here we are going to discuss about static RAM as well as dynamic RAM. Static RAM uses flip-flops to store binary information. Flip-flop is a 1-bit binary cell that will be used to store binary information into the RAM. Each cell stores a bit, and that bit is made up of 6 transistor circuits, and it is going to retain value indefinitely if it is kept powered. Relatively insensitive to disturbances such as electrical noises. It means even electrical noise is there, it is not going to lose its electrical voltage in the transistor, so that data is safe. It is faster and more expensive than dynamic RAM. Now what is DRAM? In DRAM, each cell stores a bit with capacitor and transistors in the form of electrical charges. Value must be refreshed every 10 to 100 milliseconds. Otherwise, it is going to be discharged and it means the data is going to be lost. It is sensitive to disturbances, means if any electrical noise is there, it is going to be discharged and the data is going to be changed. It uses reduced power consumption and larger storage capacity. Slower but cheaper than static RAM. That's why we use dynamic RAM. Read-only memory. ROM is used for storing programs that are permanently resident in the computer and for table of constants that do not change in value once the production of the computer is completed. While the production of the computer, if we wanted some programs to be stored permanently, that is to be accessed by the CPU, so that we keep those programs in the read-only memory permanently and will make it available as part of the main memory so that CPU can read the programs from the ROM chips. And generally, the ROM portion of main memory is needed for storing an initial programs. Means whenever the operating system is to be loaded, whenever you switch on the power button, the operating system to be loaded. To load that operating system, we required some program called bootstrap loader. This bootstrap loader program is going to be stored in the ROM and which is available in the main memory. So as soon as when you switch on the power, it is going to read this bootstrap loader program. And what bootstrap loader will do, which is going to load the operating system when the power is turned on. On top of operating system, other application programs are going to be executed. Since RAM chip is volatile, its contents are going to be destroyed when power is turned off. The contents of ROM remains unchanged after power is turned off and on again. That's why we can call it is a non-volatile. RAM and ROM chips are available in different sizes. If the memory needed for the computer is larger than the capacity of one chip, it is necessary to combine a number of chips to form the required memory size. What does it mean? Suppose I wanted 1024 main memory I wanted, but 1024 RAM chips are if not available, then what we can do, more than one RAM chips are combined to form a main memory. 1024 by 8, what does it mean? Totally 1024 words. Each word is of 8 bits. That is constructed with 128 by 8 ROM chips and 512 by 8 ROM chips. Let us say if my main memory uses one 512 by 8 ROM chips, and now the question is how many RAM chips are needed. So in 512 by 8 ROM, 512 words are covered, but totally how many words are needed? 1024 words are needed. So remaining 512 you can get with 128 by 8 RAM chips. To get 512, so how many 128 by 8 RAM chips are needed? These 128 by 8 RAM chips are 4 needed, because 4 into 128, which is going to become 512 words. It means 512 words of RAM, 512 words of ROM, but 512 by 8 ROM already available, one chip is sufficient, and 512 by 8 RAM chip is not there. We have only 128 by 8 RAM chips are there. So that how many RAM chips we have to combine? 4. 128 by 8 RAM chips we combine to get 512 words. This 512 plus this 512 totally becomes 1024 words of main memory is going to be formed. Now first we'll see the structure of a RAM chip. A RAM chip is better suited for communication with the CPU if it has one or more control inputs that select the chip when needed. The block diagram of a RAM chip is shown. The capacity of the memory is 128 words of 8 bits per word. We call 128 by 8 RAM. Now it has these control inputs. The first two are called CS1 and CS2 complement. We call chip select 1, chip select 2 complement. So that RAM chip is going to be selected when CS1 and CS2 complements are 1, 1. So this CS1 is 1, CS2 complement is 1. It is a meaning that the input should be 1 and this input should be 0. It means chip select 1 is 1, it is 1. If chip select 2 is 0, its complement is 1. When both are 1, 1, it is going to select the RAM chip. Correct? And we have a read control signal, write control signal, because it is a 128 words RAM. It is a 128 words RAM. So to have 128 words, each word is going to be addressed. To address each word, how many bits are needed? 7 bits are needed. How? Because 127 we have to represent in the power of 2 as 2 power 7. To address each word, we require 7 bit. So that there are 7 bit address bus is to be connected. Means 7 bit address is needed to locate the particular word in the RAM. And RAM is random access memory, will be used for both read and write purpose, so that it uses 8-bit data bus. Why? Because each word consisting of 8 bits. So 8-bit data bus it is to be connected. Now it is a block diagram of a RAM chip. And this bidirectional data bus is constructed with 3 state bus buffers. The three-state bus buffers will have a three states. One is logic 1, another is logic 0, and third one is called high impedance state. Simply we can call open circuit, means no connection with the RAM chip. Now look at this is a 128 by 8 RAM. Will have these control inputs, that is chip select 1, chip select 2, complement. So it requires 1 0 to select this RAM, otherwise the RAM will go into high impedance state. And read write control signal and 7-bit address is required because totally 128 words, which is 2 power 7. It means 7-bit address is needed to address the RAM. And it uses 8-bit data bus because each word will have 8 bits. Now look at here, what is going to happen? It is going to be selected when CS1 is 1, CS2 complement is 0, and read control input is 0, write control input is 1, means RAM is selected for write operation, input data to RAM. If read control input is 1, then it is selected for read operation, output data from RAM. In the remaining all the cases, RAM is going to be in the inhibit state. It is a meaning that it is a high impedance state. When you look for the block diagram of a ROM chip, the ROM chip have assumed a capacity of 512 words of 8 bits per word. 512 words, each word is 8 bits. 512 you have to represent as 2 power 9. It means to address each word in the ROM, how many bit address is required? 9-bit address is required. So it requires to have CS1, CS2 complement, and we don't have both read and write control signals, control inputs. Why? Because ROM is only for read purpose, not for write purpose. So means if ROM chip is selected, it is for read operation. That's why we don't have read and write control inputs. To address the ROM, we require 9-bit address, and because each word is 8 bits, so it requires 8-bit data bus. Only it is outline. It means it is going out from the ROM. Why it is out from the ROM, not it is into the ROM? Because ROM is only for reading purpose, not for the writing purpose. So direction of the arrow is from ROM to the outside. When in case of RAM, it is for both read as well as write, so that it is a bidirectional data bus. And here also ROM is going to be selected when CS1 is 1, CS2 complement is 0, so that CS1 become 1, CS2 complement is 0. It means this chip select is 0, means CS2 complement is 1, then ROM is going to be selected. This is a block diagram of ROM chip. The internal binary cells of ROM occupies less space than RAM. Since a ROM can only read, the database can only be in a output mode. There is no need for a read or write control because the unit can only read. The two select inputs must be CS1 equal to 1, CS2 complement equals 0 for unit to operate. Otherwise, the database is in a high impedance state. And to construct a main memory, we require multiple RAM chips and ROM chips, so that we have to map the address. We call memory address map. The interconnection between memory and processor is established from the knowledge of the size of the memory needed and type of RAM and ROM chips available. The addressing of memory can be established by means of a table that specifies the memory address assigned to each chip. The table called memory address map. The memory address map is a pictorial representation of assigned address space for each chip in the system. So to demonstrate as an example, assume that a computer system needs 128 bytes of RAM and 512 bytes of ROM. The RAM have 128 byte, needs how many address lines? 7 address lines. Where the ROM 512 bytes need how many address lines? 9 address lines. So means these address lines are different. So using this, we can able to select RAM chip or ROM chip. Which RAM chip is to be selected, that is going to be decided by representing in the form of a table we call memory address map. Here you observe, I want to construct 1024 by 8 main memory. Now to construct 1024 by 8 main memory, I'll be using one ROM chip of 512 by 8 ROM, and I have to use 128 by 8 RAM chips. How many RAM chips are needed? 4 RAM chips. Okay. Now to address RAM, we require 7-bit address. To address ROM, we require 9-bit address. And to address the main memory, we require how many bits? 10-bit address. Correct? Why 10 bits? Because 1024 you can write as 2 power 10. It means 10-bit address is required to address the main memory. In the 10 bits, least significant 7 bits will be used to find RAM address, and least significant 9 bits are used to address the ROM, and the 10th bit will be used to select either RAM or ROM. So how this is going to be discussed in the table. Now look at, we have 4 RAM chips and 1 ROM chip, and here I am showing you the hexadecimal address, and the address bus will have 10 lines. I'm representing 1 to 10. And these 7 least significant bits are common for all the RAM, even it is common for ROM also. But look at how many RAM chips are there? Totally 4 RAM chips. Which RAM chip is to be selected? The address belongs to which RAM chip is going to be decided based on the 8th and 9th bit. If 8th and 9th bit is 00, it is going to select RAM 1. 01, it is going to select RAM 2. 10, it is going to select RAM 3. 11, it is going to select RAM 4. And 9 bits address is also will be used for ROM chips. In that ROM chips, 8th and 9th bits are going to be deciding which RAM. But you observe these 1 to 9 bits are common for RAM and ROM. But whether the main memory address is referring the RAM or ROM is going to be decided based on the 10th bit. So if the 10th bit is 0, it is a meaning that it is going to select a RAM chips. If it is 1, it is going to select the ROM chips. Now this is will be used for addresses. Like RAM 1 will specifies 0 to 127. This one I am representing in the hexadecimal format. That is 4 zeros and 007F representing 0 to 127 address. And RAM 2 will specifies 128 to 255 like this. RAM 3, RAM 4, and ROM will specifies the address 512 to 1023 address. Correct? So it is 0 to 127. This is 128 to 255. Like this, it is to address. Now, we will see how this is to be designed. Okay, the component column specifies whether RAM or ROM chip is used. These are the text for your understanding what I have explained. And here RAM and ROM chips are connected to a CPU through the data and address buses. The lower order lines in the address buses select the byte within the chips, and other lines in the address bus select a particular chip through its chip select inputs. Now we'll see how to design a 1024 by 8 main memory. So to construct 1024 by 8 main memory, we require 4 128 by 8 RAMs. So RAM 1, RAM 2, RAM 3, RAM 4, and one 512 by 8 ROM. And RAM will have CS1, CS2 complement, read write, address 7. And ROM will have CS1, CS2, address 9. And all these are connected with CPU, right? Here CPU has a data bus. Look at it is a data bus, read write control signal, and 1 to 7 bits of address. 8th and 9th bits of address will be used to select a RAM, and 10th bit will be used to select either RAM or ROM. Now here I am showing you CPU connection with a main memory. This 7 bits is common, that is connected directly to RAM chips, and 8th and 9th bits will be used to select which RAM chip is to be selected. So that with 2 bits we have to select one of the 4 RAMs. For this I'll be using a decoder, as we know that decoder is going to output only one of the output lines. It means when 8 and 9 is 0 0, it is going to make output line 0 as 1, so that is connected to CS1, and if it is 1, it is connected to CS1 of RAM 2. If it is 2, means 1 0, it is going to select RAM 3. Otherwise it is going to select RAM 4 when decoder 3 output line is 1. It means when 0 0, it is going to select decoder output 0, that is connected to CS1 of RAM 1. Like this decoder output 1 is connected to CS1 of RAM 2, decoder output 2 is connected to CS1 of RAM 3, decoder output 3 is connected to CS1 of RAM 4. Okay, now, and even these 7 bits are common for addressing the ROM, right? And this ROM uses 9 bits address, so that 8 and 9 bits are connected to the address 9. And finally, what is required? This 10th bit will be used to select either RAM or ROM. If 10th bit is 0, it is going to select RAM, correct? So look at this 10th bit is connected to CS2 complement. When 10th bit is 0, the CS2 complement is 1 and CS1 is 1, then it is going to select RAM 1. So that the 10th bit is 1. If 10th bit is 1, it is not going to select a RAM. If 10th bit is 1, CS2 complement is 0. 1 0, if 10th bit is 1, CS1 is 1, CS2 is also 1. 1 1 will not select the RAM chips. It will make the RAM chip go into high impedance state. So that when 10th bit is 0, it is going to select RAM chip, but not ROM chip. But not ROM chip. ROM chip means CS2 complement of ROM chip is also 1. So it is 1 1 means ROM is not selected. ROM is selected when 10th bit is 1. So CS2 input is 0 and CS1 input is also to be 1. So to select CS1 input 1, it requires to connect read control input. Look at read control input is connected. Now read control input is connected to CS1. Read is 1 and 10th bit is 1. So its complement is 0. 1 0 makes this ROM chip is to be selected. And similarly, this write control inputs are connected to the all RAM chips because write control signal is not there with the ROM. Okay, and based on that, it is going to transmit the data to or from main memory through data bus. So all these are connected with the data bus. Fine. This is about the CPU interconnection of the main memory, which is composed of 4 128 by 8 RAM and 1 512 by 8 ROM chips. Thank you. I hope you have understood clearly. If you like the video, please do like, share and subscribe, and don't forget to share with your friends. Thank you.